Okay. We want to factor fully for all 4 of these. So here is some work from the first one. And a couple of things that I want to go through is sometimes, like a lot of these, we have the right answer, but there's little things in here logistically that we can do to make our solution better. So in this first solution for the first one, this is the first one, right? Yes. So in this first solution, it looks like the person tried -1 first with synthetic division, and it worked. And because they tried -1 and it worked, they got x plus 1, 2x squared minus 15x minus 8, and then they factored that completely to be x plus 1, x minus 8, and 2x plus 1. So that is the right answer. A couple things on this one. With the division statement here, okay, with your division statement, write out the complete division statement. So this is what we started with, and it's equal to x plus 1 times 2x squared minus 15x minus 8, and then equals again x plus 1, and here we could write 2x plus 1, x minus 8. So as far as writing things out clear, this would be nice if we had the complete division statement. Yes? 2x cubed. That is a cube. You just don't see the bottom part there. Oh, perfect. That was a nice save. Maybe not. Okay. So in this solution, writing out that division statement would be nice. This solution is also doesn't show the factor theorem at the beginning that they found out that it was equal to -1. But if you show that with synthetic division, that's okay. But I would ask for this division statement to be written out more fully. Here is another example 1. Is this? No, this is example 2. I think I have another example 1. Example 2. Example. Here's another example 1 at the top. Okay? Same sort of solution given here. Again, if I look at this top part here, the division statement isn't completely written out. And some things here, there's an equal sign right, I mean this is the next one, but just looking at this part right here, is this synthetic division equal to this? Is that what we're trying to say? Does synthetic division equal something else? It's kind of, we have to be careful with our algebraic statements. So we want, like I said, I wanted you to write this clear, just like you would do on a test. So some of these little details inside, we want them clear. This is the second one. This is the last one. This is the second one. Okay, so let's go on to the second one. So again, here's a solution where synthetic division was done at the beginning. Got a remainder of 0. Again, a division statement could be written out. But now you've factored it once and you get an x cubed. So you're going to have to go through the same process again. So they've done synthetic division off to the side again to figure out what would be next. They write it out again, and then they can factor this part. Notice, okay, so first of all, there should be something on this side, which was the entire thing to begin with. Then all of a sudden here, they decided not to write those two. Just to be careful that, just like in a proof, when you're doing your algebraic work, always show what happens next is equal to what was before that. So I'm being really picky here with the details. But then this is the right final answer. Sometimes in grade 12, if you forget a bracket, they'll take off an additional half mark on the final exam. There are 10 E errors on the final exam, which are common errors. And forgetting a bracket is a common error, and you lose a half a mark once on your final exam if you forget a bracket once. If you forget a bracket 18 times on your final exam, you lose a half a mark only once. But better not. Yeah, I know I'm gonna do this, so I'm gonna do it over and over again. Arrowheads, I know I forget my arrowheads, so I'm not gonna do it ever. and just lose that half a mark. But if you lose all 10 of those half marks, that's 5% of your exam gone on little errors. So we want to practice doing things in a formal way. So this was example 2, one method. Here is another example 2. In this example, we see the division statement. So this is really nice. So again, they started with synthetic division, found a factor that worked, wrote out the synthetic division. They showed their work with the remainder theorem here. I really like, after they got it equal to 0, that they wrote out that x plus 1 as a factor. And then used synthetic division again to get their new statement. Wrote out their division statement fully again, and then factored. So overall, this is a really nicely organized, well-flowing solution, because every step follows and every part of it is written out. So if you're looking back at a way to write things out, you can look back at this example, because this is really nice. Here we got the same sort of thing. We notice that x plus 1 happened twice. It's okay to write that as x plus 1 squared. But again, the organization of this one is a little bit all over the place. They got the final answer with a square around it, which is good. But some things like the synthetic division equal to this, the division statement's not written. And this is the third one. Okay. So here is our third one. Our third one was x to the 4 minus 13x squared plus 36. And factored fully, it becomes x minus 2, x minus 3, x plus 3, x plus 2. So that is a correct answer. Again, we see some of those things we've talked about already, about the division statement not being written again. But if you didn't do it for your first one or your second one, you're not doing it for your third one or your fourth one. And that's why we go over things like this. Now, this works. The reason I pick this example is I wanted to show you, so I've got x to the 4 minus 13x squared plus 36. I'm going to just change those to x squared minus 13x plus 36. How do you factor that? Now, I can't just change that, but if you had that in green, could you factor it easy? It's a quadratic. What would it be? It would be x and x, right? 9 and 4 with minus signs in between. Is that good? Okay. What times what is x to the 4? X squared and x squared. And then you have minus 9 and minus 4. Does the outside and inside make negative 13x squared? Yes, it does. And then you have your difference of squares, x plus 3, x minus 3, x plus 2, x minus 2. So this one could have been factored with that shortcut, which is just noticing that it was just like regular factoring, but instead of having the variable x, we have x squared squared and x squared. No, that box is wrong. X squared all squared and x squared all squared and x squared there. So that's like your variable x.
And we can use the shortcut?
You could use that if you got ones in this form, right? So some things to look for. Does it have 3 terms like our normal quadratic factoring? Yes. Could you substitute? And what some people do in a question like this is they pick a different letter. What's your favorite letter in the alphabet? Don't pick X because we used it already. C? So you say, let C equal X squared. And then that question becomes C squared minus 13c plus 36. And then you could say, well, that's easy to factor because it's got to be c and c minus 9 and minus 4. And after you've factored it, you substitute back in, well, c was x squared. So this is x squared minus 9, x squared minus 4. That's an advanced factoring technique that allows you to use that shortcut. Because what you do is you change something that doesn't look like a quadratic into a quadratic. So you can factor and then change it back afterwards. And then you could factor from there. And the last one that I added at the end, we have one solution here. So we use synthetic division. And here's our first example of one where the first factor that you tried didn't work. Okay? And I really like this off to the side. They tried it, didn't work. They write x plus 2 is not a factor. Tried another one. It didn't work. So x minus 5 is not a factor. Tried another one. It worked. Finally. So x minus 1 is a factor, and they have the x minus 1 out in front, then x squared minus 7x minus 10. And this is something that I wanted to point out for all of them, but it shows up in this one, is when you're done, the answer that you get should equal the original, and it should equal after factoring the thing that you have before. And we should always do a quick check to see if things work. So in this one, if we look here, we've got a minus 2 here and a minus 5 there. Minus 2 times minus 5 is positive 10. And we had a minus 10 here. Okay, now I picked these numbers on purpose so that you would be so tempted to do that. Because minus 2 and minus 5 makes minus 7, so you're like, yes, I found it. And you won't even notice if you don't do this little check at the end. So this question actually, when you're done, your division statement, we've got x cubed minus 8x squared minus 3x plus 10 is equal to x minus 1 multiplied by x squared minus 7x minus 10. And that is factored fully. You can't factor the last part. You can try for a long time, but it doesn't work. And sometimes you will get questions where part of it is not factorable. That's not nice. That's cruel.
Yeah, we're going to sit there for like 20 minutes and go.
Yeah, no, see, we're going to be sitting there for like the entire time trying out different things.
It can happen. It happens. In real life, it happens more often than not, because the nicely factored ones are all like pre-made teacher questions. But when you get into real life, you have to use the quadratic form. Oh yeah, we're in fantasy math class. All right. Okay. So something to look back. So I'm going to go to this solution here. When we do things, when we factor out something, you could just do a quick check just with your first and last terms. So you factored out the x plus 1. Does the minus 4 and the 1 give you minus 4 at the end? Does the x and the x cubed give you x to the 4 at the front?
Yep.
So sometimes I just do a quick check with my first and my last terms just to make sure things are following. And then when we're all done, does 2 times minus 2 times 1 times 1 equal negative 4? And does x, 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 all the first ones equal x to the 4? And that little check, because if you are going to make a mistake somewhere along the line, then that check at the end will show that you've made a mistake somewhere along the line. It doesn't tell you where you made your mistake. That's the problem, because these are big questions and that mistake could be anywhere. And if something like that happens, sometimes it's best just to leave the question, go on in your quiz or your test, come back to it later and start from the beginning, because it'll be faster to start from the beginning and redo it than to look for a little mistake. Because sometimes it's really hard to see that you did something like negative 4 plus 6 is negative 2. And because it's so close, right? You see the numbers and it makes sense that it should be 2 and you just missed the negative sign. So doing it again can help you see that. All right. That is factoring. Turn to 1.3.